Blended Podcasts. Brought to you by Blended Audio.
Hello, and welcome to Talos Talks Shit. This is episode 11?
I think it's 11,
I think it's 11. Damn, I can't count anymore, dude. And we are still looking at Google DeepMind. Google DeepMind is leading the charge, so to speak, in intelligent AI. And if you listen to our previous few episodes, you'll see how they solved things incrementally and created a fairly robust intelligence that was able to solve things outside of its initial field. And now we get to the really juicy stuff. We get to Alpha Star. Alpha Star is DeepMind's StarCraft playing artificial intelligence. Now,
it's
just
not a level 1 bot.
It's not a level 1 bot like Pubby. But just to explain a little bit, StarCraft is a real-time strategy game. So at the professional level that they played this AI at, it's a 1 versus 1 game. You get 3 different races: Protoss, Zerg, and Terran. They all have different strategies, they all have different ways of playing, and for this, they used Protoss. Protoss because I think it was the most directly trainable. It had the most sort of logical strategies for the AI to understand. And what you have to do is you start out with a couple of workers, very low-level units. From those low-level units, you have to first explore the map.
Is this how StarCraft works?
This is just general foundation of StarCraft for people who don't know. You first explore the map. You've got to find mineral resources. You mine those mineral resources, and those allow you to build items and buildings in your base. And as you build your base up, your ability to create newer, more powerful units that are capable of attacking or surveying or even more efficient resource mining and base building, you create a stronger team and eventually try and go and defeat your opponent by destroying their base. That's a very simple explanation of so many things that need to happen. So we've got to break this down, that AI up until this point was tackling perfect knowledge tasks. They were perfect data set. There were no unknown unknowns. Data that the AI knew it didn't know, but still needed to make a decision based on what it could potentially be. So imperfect information. So this is a huge step for intelligence and AIs, because as I said, it makes the problem exponentially harder to solve. And you want to just explain what that actually means in terms of
information.
Imperfect information in terms of game theory and the orders of magnitude.
Yeah, it's just so in the whole field of AI that kind of looks at playing games, the kind of like framework is called reinforcement learning. And that framework is based off another part of math called Markov decision processes, right? Now, what Markov decision processes are basically just, I can see the world, right? And I know what my last state was. So for example, I'm looking at my chess game, the state is the board now, and my last move is that I move my pawn or something. Now you get different types of Markov decision processes, right? You get fully observable ones, and for example, chess and tic-tac-toe and Go are fully observable processes. And what makes it easy about them is that you have all the information that's required to understand. So you don't have to model any uncertainty, right?
Right.
But partially observable environments For example, StarCraft, where you can only see what's in front of your screen and your opponent might be doing something on a different part of the map.
Just to note, the map has fog when you start. You can't
really?
see where things are, where people are. You've got to go explore and
That's really cool.
actually discover things.
That's dope. Yeah. So, but that's what makes it tough because as a human, you have to be able to model what do I think my opponent is doing, or do I think he is, and also concentrate on what I'm doing. So it's that extra layer of complexity because now you have two things to model: your own actions, but potentially also not necessarily other people's actions, but other parts of the environment which might have other agents.
Other people's potential actions if they are there.
And potential environments.
So what this AI needs to do is it needs to scout for relevant information. And they were actually incredibly smart. They created 2 levels of management within this AI. So one is a micro level, so that focuses on the units, the little workers and soldiers and stuff, where it goes, what they do, how they attack and defend and whatever. And the other is macro, how it manages its economy, what it spends its money on, what it spends its resources on, what to build next, etc. And these are separate processes similar to the evaluation and Monte Carlo tree from previous episodes that coagulate their data to come up with a solution. That is way, way more complex than it sounds. And let's just break it down a bit, because first they had to train AlphaStar.
Yeah.
And they used a deep neural net from that. And what they did was they input raw game data, string of numbers, which was essentially a list of units and their properties, and the AI outputs a command. But now, correct me if I'm wrong, AlphaStar was trained by self-play.
So, in fact, AlphaStar, well, the one that played at the tournaments, was trained really in the same way that AlphaGo was trained. Not AlphaZero, but AlphaGo. Okay. So it started off with strong human data, and they call it a seed. So you basically, to start reinforcement learning, because reinforcement learning is like super hard because it's a very noisy process. So when you want to start self-play, you want to get something that's okay at playing at first. Unless you can do the same techniques that you did with AlphaZero, in AlphaStar they couldn't use the same techniques. So what they did is Blizzard gave them a couple of thousand of games.
Right, yeah.
And they just did the same thing. So behavior cloning. They told the AI, so this was the position, or this was the state of the game. What do you think the strong StarCraft player did? And he said, I think he did this, and he actually did that, and then they were able to train a neural net that way. And they got it to the point where it was winning on the elite level.
So it was beating everyone in the office, and it was like an elite standard, which is a global ranking scale for everyone who plays StarCraft around the world. And
then they took that elite neural net, or like AlphaStar agent, as a seed, and they got him to just play against himself. Billions of times. 200 years worth of games.
200 years worth of games in 3 days, I think?
Yeah, it was something crazy like that.
And also, AlphaStar has destroyed the world's leading Protoss player.
Yeah.
I think he won one game out of 5. Yeah. 1 game out of 5.
Which is a pretty good score for humanity these days. One game.
But now, if you haven't seen anyone play StarCraft, you've never seen what's called APM, actions per minute. These guys are essentially superhuman in their speed. The pro players in StarCraft are essentially superhuman in their speed and ability on the keyboard.
Yeah. It's like you just hear...
Yep, so they do 350 plus unique actions per minute. That means they press and click 350 different times per minute.
I remember watching an interview with Demis Hassabis, and he was like, I can't even press my keyboard at random that fast, like, let alone have them be like well thought out moves to try win a game.
Yeah, so apparently the pros estimate about 30 of those clicks per minute are random moves, 30 to 50. Like just clicking in places that you shouldn't be. But now they locked Alpha Star at 200 actions per minute.
Yeah.
Which means that it couldn't brute force humans just by doing thousands and thousands and thousands of actions per minute. Then what they really do is they use these, because as Pubby said, the more imperfect data you have, the larger your data set is and the more difficult it is to decide on an outcome based on input data. So they use what's called a deep LSTM core, which is that same long short-term memory system we spoke about a few episodes ago, where the AI selects important bits of information and chooses to remember those, and then makes its next decisions based on what it thought was important.
Yeah.
But it also uses these very interesting things called transformer torsos. So what the transformer torso will do is will take the data points of the units and the buildings, and it will map it to a 3D space and to vectors, so that the AI can essentially throw these different things around. And while I was researching it, I thought it's kind of like what they think made Einstein smart.
Really?
The ability, they think what made Einstein smart, he had this more densely packed cortex, neural cortex. So what that meant physically was that he was able to take concepts and visualize them more clearly, and then literally move those concepts around in 3D space more easily in his brain. So like if you think about if he was deconstructing a car engine, he was probably able to have all those different parts sitting there and throw them around and whatever.
Sounds like something out of a movie.
Yeah, they think
Sounds
like
really cool. I wish I could do that.
Yeah, in terms of what they think separated Einstein from the rest of humanity in terms of intelligence, that's the one physical thing that they can find. So it got me thinking that the way these neural nets take this data, whether it's unit A in position A, unit B, so on, turn it into a 3D shape, map vectors to it, and throw these vectors around to see where would be safest to move, where would be most intelligent to move, should it attack, should it retreat, so on. And it's very interesting that it was able, after taking this strong elite algorithm or AI and allowing it to self-play and creating the alpha star that beat, I think it was TLO is the gamer's name, the knowledge of the environment and the knowledge of the ability to move and how you should move your units, because like the way these pros play is that if you're attacking, it's not just like, oh, we're gaming each other for space and high ground and whatever. These guys can calculate like how far a projectile from the enemy's soldier will fire into the space and sort of make minute movements in that they'll move the unit like 3 millimeters forward, attack, but be able to tell when to retreat, so that it doesn't take damage and stuff. And this takes humans an incredibly long time to learn, and it's very rare.
When we learn it, it's pretty much imprecise. It's not as precise.
Yeah, exactly. You can watch TLO's breakdown, and he shows you exactly where he clicked wrong and how that made his unit take more. And I mean, this is minute. The guy clicked like 1 centimeter left of where he should have, and that was like a major effect on his health and his units and whatever. And this AI is almost perfect at gaming that space.
Yeah.
So perfect, in fact, that it has created new strategies for humans.
It was actually really interesting on the whole strategy generation, the Alpha Star League.
Yeah.
Yeah. Do you want to talk about that? Or?
Yeah, so let's just see. So basically, once this thing has thrown this 3D vector around, it has several other artificial, neural net, not even neural net, artificial intelligence architectures.
Yeah.
Some which have inherent rewards to it so that it knows that it made a good move. Some that allow for it to be variable in its output stage.
Yeah.
So it doesn't necessarily need to be defined exactly in what it's doing. If the information coming in is variable, the information going out can be variable, which means we make faster decisions. And really it just uses some very, very clever tricks to allow for agents, and now these are independent agents making their own decisions and whatever based on the data they have in front of it. So instead of trying to look at all 50 of its units on the map in one go, it allows each unit to look at its own environment, make a decision based on its dataset contained within that environment, and then send that information individually back up and allow the AI to make an overall decision on it, which is quite a feat.
Yeah.
Quite a feat. And I think that's a good basic rundown of it without getting too technical. And what's really interesting is that the strategies that this AI came up with, they beat humans so effectively now that the game isn't really to try and beat humans anymore. Humans have lost. But they have now recognized new strategies in games we've been playing. I mean, the amount of collective man hours we clocked with StarCraft is probably...
Yeah, it's so much.
Yeah, unbelievable. And the fact that we now have new ways of approach and new ways of looking at it is as interesting as the fact that we were able to create something that made so many complex micro decisions per second and per minute.
Just on the whole training thing, it actually used evolutionary algorithms to train as well. So what they did is that they had these agents, right? So you have your Alpha Star agent. And in StarCraft, one of the issues is that so it's game theoretic. So have you heard in rock, paper, scissors, there's no optimal strategy that is different from the random strategy.
Oh.
So say I'm playing rock, paper, scissors with you, right? And I want to maximize my chances of winning. And I'm like, I'll maybe play scissors every 2 times and then rock and then paper, right?
Right.
If that's my strategy, and I have a rule for the strategy, and you know that rule, you can exploit me.
Right.
So you can just always play the move that is the most disadvantaged. And because I always follow this rule, you'll always be able to game the rule. Right? So it turns out that with rock, paper, scissors, the best strategy to have in the long run to win as many games in expectation is just the random strategy. So
randomization is becoming pretty important in AI as we're progressing.
So the whole idea is that in StarCraft as well, there's no optimal strategies. There's no way to play that will ensure that you win under all circumstances.
Yeah, there's no if this then that.
Yeah.
Strategy.
So what that means is that even if you become really good, if you just keep using the same strategy, there's no guarantee that a new agent won't be able to game you on that strategy and beat you. So this algorithm that you develop has to be really robust and have a large repertoire of strategies it can employ and be able to change strategies. And in order to do this, what they did is that they had this population of agents playing, and it was really like evolution. So they gave the agents intrinsic rewards, as you said, and some intrinsic reward would be like, I'm not going to tell you how much to value building a site, right? But I want you to reward yourself a little bit for how much you build, and I want you to reward yourself for how much you attack someone. So there were all these little intrinsic rewards that the agents had for themselves, and what they did is that after every run of the Alpha League, so maybe there were 30 agents, the ones that did badly and maybe the intrinsic rewards didn't lead to them winning, they culled them off, and they had some process of making offspring with the strongest AIs and then inciting that in the next round.
Evolution.
Yeah, so it was a basic evolutionary algorithm.
Okay, yeah,
that was really cool because it helped them learn strategies against each other because they're all always playing against each other and they all have different goals. So, for example, I might be like, I want you to play Protoss, and your goal is to beat Terrans.
Right.
Or something, right? And someone else's intrinsic reward might be like, I want you to try win, but you have to build X amount of resources. You can't build more or less of that than something. So all these different agents have all these different strategies, and it's really like a evolutionary, like I don't know what the name is, but like branch of all these different agents that all play well, but in different circumstances. And because they're exchanging information after each genetic swap to make the new population, they all exchange what best practices and best strategies are under a wide variety of circumstances, which what made the algorithm extremely strong.
Wow, so that's amazing. I'm just digesting that for a second.
Yeah, it was really, really cool.
Because we talk about all these things and we tie it into these nice, neat little packages, but Pubby and I were talking about this before we started recording today. The code, the amount of code and the amount of shuttling data back and forth and just the amount of man hours, I think, needs to be paused and appreciated here.
Yeah, it was some really, really amazing work.
Yeah, because I mean, essentially everything this thing does, other than the ultimate decision it makes, is pre-programmed.
Yeah.
So the only thing that's not pre-programmed is the outcome.
Yeah, it's its behavior, but you have to set up the architecture. You
Yeah.
need to show it the data. If you show it bad data or you have a bad way of updating your estimates based on the data that you've shown, you're going to get bad results. So yeah.
Madness. I think that is a really good point to leave off for today. Alpha Star that's made waves. No one really knows what's next after Alpha Star for DeepMind, and that wraps up our little rundown of DeepMind. In the next couple of episodes, we'll be talking about, I suppose, their direct competitor.
Closest thing to it, I suppose.
Yeah.
Well, I know of, at least.
Yeah, but we can also talk about how competition is changing and how OpenAI may save us all. Yeah, thank you, Pubby. Thank you, Alex.
Thanks,
Thank you, Blended. Thank you, everybody. I am still digesting what Pubby just left us with, so we will see you soon. Cheers guys.